Hi, third graders. We are moving on to our station number 2. We are exploring the question, how do magnetic forces and static electricity affect objects? So we are going to move on to station 2, just like last time. If you have the supplies to do this at home, you can do it with me. If you don't, that's okay. You're still going to do the lab and you're going to watch the different videos that I provide for you and complete the lab sheet that way. So both ways, you do have to watch the video and you do have to complete the lab sheet and submit it. It doesn't matter if you don't have the supplies at home. We've done it for you. So here are the supplies in case you want to see if you can do it at home with us. So you need to have one metric ruler. That means that there are centimeters on it. You need to have masking tape, or really any tape would do. You need to have a paper clip. You just need one. And you need to have 4 different magnets. So you can see that they have 4 different magnets here. You need 4 different magnets at home. They don't have to be these exact ones, just 4 different ones. So here is your station 2 close enough directions. These are your lab procedures, so they are in order from what you do first to what you do last. So it says, tape the ends of a metric ruler on top of the table or desk. Place a paper clip next to the 0 on the ruler. 3 is predict the distance at which the paper clip will be attracted to the magnet. Record this prediction on your data table. Starting at the 30 centimeter end, slowly slide one of the magnets along the edge of the ruler toward the paper clip. Stop when the paper clip attaches itself to the magnet. Record the distance in centimeters on the data table. Repeat with the other magnets. So we're going to get started. You should have your lab sheet up, split screen with me, or you could print it off if that's easier for you. But you are not going to want to do this afterwards. You should do this before. So make sure that you are split screen with your lab sheet, please. Great. So we are starting where that blue circle is around your lab sheet, where it says answer, answer. This is magnet 1. So we're going to talk about magnet 1 first. The very top box under magnet 1 says prediction of how close your magnet must be to the object. So what you're going to do in just a second, I'm going to start the video and I'm not going to play it. I'm going to just pause. And I want you to decide, how close do you think that magnet needs to get before the paper clip will attract to it? So if you think I'm going to need to move it until it hits 17, and then the paper clip will go, then you would write 17 centimeters in that box. You decide, I'll start at 30 and I'm going to end up moving it, but you need to predict. So make it a good assumption or a good guess about what point it will attract that paper clip on. So I'm going to play it for you and pause so that you can write your prediction. All right. Here is the magnet. Okay. I'm going to start it at 30. In your box, please now write the number that you think it's going to have to stop at for that paper clip to be attracted to it. Do that now. All right, do you have a number in that first box? If you don't, pause it until you do. Make sure you wrote centimeters afterwards, cm. And now let's test your prediction. We're going to write the actual number underneath your prediction. Let's see how close you were. So it's starting at 30. And it's moving closer, closer. Not quite yet. Still not attracted yet. Oh, now it has. So you're going to look at the front side of that magnet. What is that magnet close to? Well, I see it's between 1 and 2. So what's halfway between 1 and 2? 1.5. So on your chart, okay, on your chart, you're going to write 1.5 underneath your prediction. So this bottom answer needs to be 1.5 centimeters. You should have your prediction on top and the real answer on the bottom. Okay, make sure you have that. If you don't yet, please pause the video. Moving on. Magnet 2. There are check marks because you should already have numbers there. We're on to magnet 2. Magnet 2 looks like the one in this video picture right here. So please right now make your prediction. How close do you think magnet 2 will get before the paperclip moves it? How close do you think magnet 2 will get? Put your number and then centimeters. All right, if you have it, it's time to continue. If you don't, please pause the video and finish it before you press play. Let's see what the actual number was. Oh, there you go. It is finished. So where's the front of that? I see it's between the 2 and the 3. Go ahead and write that as the actual distance underneath your prediction for that magnet number 2. You should be writing that now. All right. That means you should have an answer under magnet 2 for both of those, your prediction and your answer. It is time to move on to magnet number 3. Let's see what magnet number 3 does. You're going to write your prediction first. So magnet number 3 looks like this. We're starting it at 30. Write your prediction down. Make sure you write centimeters afterwards. Okay, it's time to play. If you have not written your prediction down, go ahead and pause the video until you have written it. Okay, the magnet has been attracted to the paperclip at this point, or the paperclip was attracted to the magnet. So I'm going to go back to that point so that you can see closer. Sorry. We'll watch it once more quickly, and I will pause it. All right, look at the front of that magnet. What is it between? I see it's between 1 and 2. Go ahead and write that number down on your paper under the actual. Don't forget to write centimeters afterwards. Okay, at this point you should have answers for magnet 1, 2, and 3. We are finally on to magnet 4, and this is our last magnet. So we're going to make our prediction first, just like we have before. This is the magnet this time, it's circular. What do you predict will happen with the attraction to that paperclip? Do you think it will be more than it had been before? Write your prediction on the top box for magnet number 4. Don't forget to write centimeters. If you're still writing, pause the video. We are now going to go test it out. All right. I think this one looks like it's at exactly 1. So for that last one, you could write 1 centimeter in the bottom box for magnet number 4. You should now have answers in all 4 boxes. That's why there are check marks. You should have numbers. Double check that you wrote cm for centimeters after each one of those numbers. And it's time for us to move on to the questions. So your first question is, did the magnets need to be touching to move? So your question here, did the paperclip have to be touching the magnet? Sorry, that was kind of phrased weird. Did the paperclip need to be touching the magnet for it to move? No, it didn't. You can write no, the magnet did not need to be touching the paperclip in order for it to move it. Your second question, if you didn't finish that first one, go ahead and pause. Your second question says, does a larger magnet always have a stronger force? What do you think? In our example, one of our larger magnets did have the stronger force, meaning it could pull that object from farther away. But in real life, magnets that are larger don't always have a stronger force. It's true. Sometimes there are really large magnets that don't have a very strong force at all, and there are really small magnets that have a stronger force. So does a larger magnet always have a strong force? The answer to that is also no. The force depends on the magnet itself. You can go ahead and write that. And once you have everything filled out, that means all of the top boxes, the 2 questions on the bottom, then you may submit this to Schoology as an assignment. Good job. This is Magnet Station 2.